All right, so I want to actually develop the pattern because depending who you had, your teacher may have actually done this when you were in geometry, but sometimes students think it's magic. If this is a leg of a 45, 45, 90 triangle, what do you know about that? Both the legs are the same, right? It's isosceles. Okay, so if we do a little famous theorem, right? Pythagorean theorem. We can go leg squared plus leg squared equals hypotenuse squared. Well, what's an L squared plus an L squared? Please get this right. 2L squared. There we go. So if we want the hypotenuse by itself, what do we need to do? Square root both sides. Okay? The square root of L squared would be L, and then we'd have a square root of 2. I don't know what I just wrote. That was really weird. Okay, we'd have L and a square root of 2 equals hypotenuse. Oh, I'm apparently going to have handwriting issues today. That's where this pattern comes from. Do you remember seeing this? It was usually written x square root of 2. Does that sound familiar now? Yay! Just Pythagorean theorem, okay? All right, let's practice it. So if this leg is 14, the other leg is the same, which is y. And the hypotenuse is leg times the square root of 2, or 14 square root of 2. Good job. Okay, another easy one. The hypotenuse is 7 square roots of 2. The legs are each 7. We good? Because this is, we divide a square root of 2 off each one. That means the legs are each 7. That's supposed to be an L. I don't know what it is. Doesn't look like an L. All right. Now we're into not so easy land. But if this leg is this, what's this leg? Same thing. And what do we have to do to find the hypotenuse? That disgusting leg times square root of 2. Okay? We call it a hairy leg. All right, we got to multiply these together. We get square root of 20 over 2. Square root of 20 is the square root of 4 times square root of 5 over 2. What's square root of 4? It's really just 2, so then those cancel out, divide out. We get square root of 5. So that was weird, right? We had some nastiness on the legs, and somehow this turned out nicer on the hypotenuse. Okay, this is one they love to do. They love to trick us because there's no square root of 2 there. But there is. It's just in disguise. Okay, so this is leg times square root of 2 somehow became plain old 2. So if we divide them both by square root of 2, and we do a little magic, we just get square root of 2. Because the square root of 2, square root of 2, and square root of 2 times square root of 2 would be 2 here, right? Now, do you see how it's in disguise? All right. Now we have the good old 30, 60, 90, which comes from, okay, it comes from an equilateral triangle, guys. What do you know about an equilateral triangle? All the angles are 60 and all the sides are the same, okay? Well, guess what happens when we drop an altitude or a median or a hypotenuse or altitude, median, angle bisector. They're all the same line. Okay, couldn't remember that word. This makes this a 30 because we split this in half. This is still a 60 and this is a 90. Are we good? Okay. Now, I could call this guy side. Okay, or I could call him hypotenuse on this one. But if we call this like x, uh-oh, then we have an x over 2, right? Okay, so we're going to go undo, 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 undo. What if we want to call this x? Then this whole thing is a 2x over here and a 2x over here and x here. Is that better? Okay, so we have a 2x and an x and this other mystery. Most famous theorem of all, I don't know what I just tried to say, on this little guy right here. We'd have leg squared, this guy down here, right? Plus question mark squared equals 2x squared. All right, what is 2x quantity squared? 4x squared. What do you want to do next if we're trying to get the question mark? Subtract an x squared, so we have something squared equals, uh-oh, sounding familiar yet? If we square root both sides, we have the question mark is the square root of 3 times x. That's where the square root of 3 comes from. Remember that now, that it had a square root of 3 in it? Okay, so I would really prefer that we think of it this way. We have a hypotenuse that's 2 times the short leg. This guy is the short leg. Oh, it's going to be a day. And then this is the long leg. You know why I know that one's longer? Because it's opposite of the 60 and the shortest leg is opposite the smallest angle. Remember all this geometry? It's just coming back to you. So this one is short leg times square root of 3. Everybody remember this pattern now? Kinda, sorta? Okay, so across from the 60 is supposed to be something. I hate writing x because they have x's and y's and they're not in the right spot. Okay, it's supposed to be the short leg times the square root of 3. How's that? So what does that tell you? The short leg is 7, which goes here. And what's the hypotenuse? 2 times the short leg, right? Which would make this... Am I losing some of you? You okay? All right. This is our favorite, right? This is the really easy one, because across from the 30 should be the short leg, which is just the plain old x. Across from the 60 then should be short leg square roots of 3, which would be 4 square roots of 3. And across from the 90, or the hypotenuse, is 2 times the short leg, or 8. Too much? Too fast? We're good? Okay, then of course we get to the nasty ones. Well, this one isn't all that nasty. What do you do to the hypotenuse to get what? To get the short leg, you divide by 2. And we're going to leave these in exact answers. And then to get the long leg, you take the short leg and multiply by the square root of 3, which is disgusting, yes, but we're just going to leave it. Okay, this is the most painful of all. This is the square root of 3 in disguise. Okay, so the short leg times the square root of 3 somehow became a plain old 13. What do we need to do? So we have 13 over the square root of 3, or 13 square roots of 3 over 3, right? If we multiply by square root of 3 over 3, those are equivalent. Do I need to show that, or are we good? Okay. That you just told me is the short leg, which is U or V? V. And once we know the short leg, how do we get to the hypotenuse? Multiply it by 2, which would be a lovely 26 square roots of 3 over 3. Because you multiply it by 2 over 1. Everybody okay? Just like that. Good. Hey, Kendra, the stuff is back there, just like usual. This is Kendra. She must be switching from 7th period. So this is class 3rd period. Yes, this is my very favorite class. No, we just record in this class every day, so I tell them they're my favorite. But really, I love all my classes. It's all right. No one's going to watch it. We all know that. Okay. All right. These are all mixed up on here. You good with the rest of this? You want me to do one? Pick one. 20, what? 22. Okay. On 22, what do we know right now? Okay, there's a 45, 45, 90, and there's a 30, 60, 90. In the 30, 60, 90, we know the short leg. So what do we have to do? 10 square roots of 3 goes where? Yeah, across from the 60 goes the short leg times the square root of 3. The hypotenuse down here, which we really don't need to know, would be 2 times the short leg, or 20. Okay. This is a 45, 45, 90. So one leg is 10 square roots of 3. So the other leg is also 10 square roots of 3. And the hypotenuse is 10 square roots of 3 times the square root of 2. Because it's a 45, 45, 90, right? So it's 10 square roots of 6 is what x is. Okay. I didn't put one on a quiz like that. You just got to know the basic patterns. All right. So shortest video ever. You just need to finish this worksheet. Good?